We've now seen how to express the probability of y equals +1, probability y equals -1, and we're going to plug those into the log likelihood before we take its gradient. This is still part of that very, very optional derivation that we're doing of the gradient of logistic regression. Now we have probability y equals +1, probability y equals -1. We can go ahead and plug those in to our log likelihood function, and with the indicators and all that good stuff. Let's see what happens. So I'm going to go ahead and plug in these definitions of the probability of y equals +1, y is equal to -1 into log likelihood. It turns out the log likelihood is going to simplify to a pretty cool term, and we're going to take the derivative of it and derive the derivative that we're hoping for. So here we go. So I'm just going to first plug in the probability that y is equal to +1 into the first term. So we're going to have that the log likelihood function is the indicator that y is equal to +1. And so we're only going to deal with one data point for now, and then we're going to sum over the data points later. So of the log of that ratio, so 1 over 1 plus e to the minus w transpose h of xi. This is the particular data point we're dealing with. So that was easy. That was the first one. Now, for the second term here, we need to plug in the probability y equals -1, but it's a little bit annoying for a derivation that we have an indicator that yi is +1 and another indicator that yi is -1. So we're going to take this indicator that yi equals -1 and substitute it with something else. So let's do a change of colors transformation here. And just remind ourselves that the indicator that yi is equal to -1, this takes value 1 when yi is equals -1, can be written as 1 minus the indicator that yi is equal to +1. So if you think about it, when yi equals -1, if yi is -1, then the left side here is 1, and the right side is also 1. If yi equals -1, the left side is 0, and the right side is 0. So let's plug that in, what we just learned. And so from the first term here, we get 1 minus indicator that yi is equal to -1. And we're going to plug in the definition of the probability that y equals -1. So that's log of e to the minus w transpose h of xi divided by 1 plus e to the minus w transpose h of xi. Phew. Great. So now we have our two terms, and now we're going to move a couple of things around and simplify the equations pretty significantly. So let's go ahead and do that. Okay, let's go back to our change of colors transformation. We're dealing with the first term. So the first term is the red term. So let's go back to the red term. And let's see what the log of 1 over 1 plus e to the minus w transpose h of xi looks like. And the log of 1 over something turns out to be minus the log of something. And the something here is 1 plus e to the minus w transpose h of xi. So plugging that in, we get the indicator that yi equals +1 that multiplies minus the log of 1 plus e to the minus w transpose h. So we're going to write here log of 1 plus e to the minus w transpose h of xi and put the minus sign out here. As for the first term, so now let's look at that famous second term and expand it out. So let's go back to our blue. And so the coefficient here stayed the same, 1 minus the indicator that yi is, that should say positive. So yi is positive, sorry about that, of the log of that ratio. So let's explore what that log of the ratio looks like. So the log of e to the minus w transpose h of xi divided by 1 plus e to the minus w transpose h of xi. And so what does that look like? That looks like it's the log of the ratio, so it's a difference of the log. So it's the log of e to the power of minus w transpose h of xi minus the log of 1 plus e to the power of minus w transpose h of xi. Let's know two things. First, the second term is exactly what we had up here. So things are starting to look very similar. And what is the log of the first term? And here's another log trick. Log of e to the something, say e to the a, is exactly equal to a. So in this case, the log of e to the minus w transpose h is just minus w transpose h of xi. So plugging that in, we get our coefficient that multiplies minus w transpose h of xi minus the same term as the other side, log of 1 plus e to the minus w transpose h of xi. Okay, going a little slowly. And now you can shake things around, move things, lots of stuff cancels out. I'm not going to go through that in detail, but you're welcome to do it. I'm just going to do a change of color transformation, go to purple, which is a color I love, and just write out what the answer is. And the answer here becomes log likelihood can be written as, for a particular data point, as minus 1 minus the indicator that it is a positive example. So yi equals plus 1. That multiplies w transpose h of xi minus the log of that crazy term, 1 plus e to the minus w transpose h of xi. So we started from the log likelihood function. We went through a bunch of derivations and maths, which you can explore if you want, and we ended up with this much simpler form. And now we're going to take that simpler form and take its derivative.